is adding and subtracting polynomials, and then we are going to get started on multiplying polynomials, which is section 7.7. Where did it just go? That'll be your homework. Why is it not there anymore? Come back, come back, come back. There we go. We're in action. Okay, so put the following examples up here. Less writing today, which is nice on your part. We're just going to do examples. We got all of our vocabulary done in section 7.5. So now we're just going to add and subtract polynomials. So here's our first polynomial. I've got 3 terms to start out. I've got a 12p to the third plus 11p squared plus an 8p to the third. Are any of those terms, or any of those monomials, I'm going to use terms and monomial interchangeably, are any of them like terms? Which ones? Yeah, so notice here I have 12p to the thirds, and notice at the end I have 8p to the thirds. So if I were to combine 12p to the thirds plus 8p to the thirds, now be careful, because people make that mistake.
20p to the 9th.
Nope. It stays the third. Because what's really happening, don't write this, just watch. If I made 12, oh goodness, 12p to the thirds, right? 3, get the idea. And then I added 8 more to them, they still stay p to the thirds.
Oh, so it's still 20.
Right, so now I would have 20p to the thirds if I drew them all out.
Okay.
Right? Okay. Does the 11p squared have anything to combine with? Nope, so it just goes into our answer. So when I add it, my like terms, I got 20p to the third plus 11p squared.
Which is a quadrinomial.
Yes, let's practice this.
31.
So the degree is 3. Your highest degree is 3. So it's a cubic binomial.
31p to the 5th.
Nope, because they're not like terms anymore.
Yes, they are. They're both p.
Because it's 2. Cubic binomial, if I had to classify it.
Does it have to be the same exponent?
So Aiden's asking, why would I not take this to 31p to the 5th? They're not the same exponent, right? My degree for this is 3, and my degree for this is 2, so they no longer have the same thing, so I can't combine them together.
Why can't you do like 31 and P3 and P2 or something?
No, because they're not like things. I can't have 12 apples or 20 apples and 11 oranges and then combine them together and say I've got 31 how would you say it?
Yeah, but
Orpals.
No, see, that's like, no, 'cause they're both P, so you can't say apples and oranges, because...
But they have an exponent that is different. It's p to the
But then
third.
why did we add them before? Why did we add exponents before?
Because they both had a p to the third. They were like
A
terms.
couple lessons back. No, we multiplied.
Because we were multiplying. If it was 12, oops. If it was 12p to the third times 8p to the third, then I would multiply and then add the exponents to get p to the 6. But we were adding. But keep that in mind, because when we get to multiplying, you're going to have to think back to that. Okay? All right, so for the B one, we have 5x squared minus 6 minus 3x plus 8. So do I have like terms?
Yes.
So my highest degree is 5x squared.
So the answer is 5x, 2...
So the 5x squared stays.
Plus 2.
What's my... Well, okay, let's do that. So I have a negative 6 and I have a positive 8, which would go to a plus 2.
Minus 3x.
All right. Is that written in standard form?
Yes.
What can I do to put it in standard form?
5x squared minus 3x plus 2.
Good. 5x squared minus 3x plus 2 would be my final answer. You should try to write your answers in standard form. So your highest degree to your smallest degree. Guys, got this?
Yeah.
Okay, so in these examples, I had 3 monomials being added together in A, and B, I had 4 monomials being added together. So can you add together a bunch of monomials? Yes?
Yeah.
Okay, so now let's change it. See if you can do these. Make them a little bit more complicated.
T squared plus.
For part C, we've got t squared.
So,
Do it in your head or on your paper first. Don't say it out loud.
why do I want to run my paper?
Well, don't ruin it for everyone in the room. T squared plus 2s squared
Things have to have a number.
minus 4t squared minus s squared. You can go into the pot, Amanda. All right, how many t squareds do we have? We'll bring them together. -3 t squared,
Yeah.
because it's +1 minus 4.
You got a 1 in there.
How about your s's, s squareds? So it would be plus or minus? Plus s squared, good. Now quick question. The degree of both those terms is 2. Which one goes first?
The S.
Usually you go alphabetically once you get to the same degree. Yeah. I'm not going to be picky about that. If you would leave this as an answer, that would be fine. So my 2 variables are s and t, and s goes before t. So I would technically write my answer as s squared minus 3t squared.
That's sort of dumb.
They have the same degree. So then once they have the same degree, then you go to alphabetical. I won't do it that way. If you left it as -3t squared plus s squared, I'd be fine with that. All right, get D written down. 10m squared n plus 4m squared n minus 8m squared n.
6m squared. N.
Yeah. You're correct.
That's all.
Good. You guys get that?
Yeah.
Are all of my variables the same in each of those terms?
Yeah.
Yes. So 10 plus 4 is 14. 14 minus 8 is 6. M squared n. Yeah.
Yeah.
What if you had like a separate m, would it still just be added onto it?
Yeah. Okay. Nothing too crazy right now? All right, moving on. Now we're going to take a binomial and add a trinomial to it. So before we were doing a bunch of monomials added together. Now I'm going to take a binomial, meaning I have 2 terms, and add to it a trinomial. But do you know what? Nothing is going to happen or change from what we just did. Ultimately, what I could do is just ignore my parentheses for now and add all my like terms.
Can you explain what a monomial is?
So if this plus 5 wasn't there, that would be a monomial, 4m squared.
What's the other word?
Binomial, trinomial. There's 3 terms.
Oh, so monomials when there's 1.
Yes.
Oh, I feel you.
All right, so let's look what's inside our first set of parentheses. I've got a 4m squared. Is there an m squared term in the trinomial that's being added to it?
Yes.
Yeah.
So if I have 4m squareds and I add another m squared, I'm going to end up with 5m squared. Good. Now here I have a 5. And I've got a 6 over here.
Wait a minute. You got a minus an M.
I know, I'm getting there. Thanks. You're thinking. You're thinking. So now I've got rid of everything here, but over here I've got a 3rd term. Does it have anything to add to it over here? So I'm just going to bring it down to my answer. Is this written in standard form? What do I need to do to write it in standard form?
5 m
Good.
squared minus m plus h.
Good.
I don't know. Look at it. Is it snap?
It's raining.
Raining. Of course it is. Yeah, it's raining.
Okay.
For what, lax?
Questions. Some people, I'm just going to erase this. You can just watch. Some people like to add vertically. If you're one of those types of people who likes to add vertically, sometimes you'll see some people move this underneath. So they would write it as 4m squared plus 5, and then I would do m squared minus m plus 6, and then do an adding like that. If you're more of those vertically thinking type of people, right? So we would get 5m squared. It's kind of like having 0 m's. Would get you minus m plus 11.
Wait, so this is another way we can do it?
Yeah, it's just another way to visualize it, if that helps. Me, I just go linear and go straight across. Okay? All right, so let's do another one. Here's a binomial plus a binomial.
7xy.
Don't say it out loud, please, Colin. 10xy plus x plus negative 3xy plus y.
Is 7xy. Is that right?
Yes, but can you let people who are actually taking notes get time to write it down? That'd be nice. All right, so we got 10xy.
Technically, doesn't that quote not make sense? Because a smooth sea does make a skillful sailor. Because I like.
I don't know what you're talking about. That like came out of nowhere. 10xy and a negative 3xy makes 7xy. Does this x have another x to add to it on this side? Nope, so it comes down. Does this y have anything to add with? Nope, so it comes down. No. No, so I'm done. This has a degree of what? 2, right? Add your exponents. This has a degree of 1. This has a degree of 1. X comes before y, so I do have it written in standard form. Got what?
I thought you said like if you take it as like for the other equation, O's and N.
Yep.
But I'll just use this example. If it's like a x by itself, don't you add it to the thing? I thought you said it's.
Well, you add it at the end, but there's nothing else being
okay,
added
so
to the
it's
x. Yeah, no, don't combine it to that. You can only do your like terms. Okay. Good with that?
Yeah.
All right. Binomial plus a polynomial of 4 terms. So we got 6x squared. Colin, sit. Keep your mouth shut. 6x squared minus 4y. And then we're going to add to it 3x squared plus 3y minus 8x squared minus 2y. Colin, what did I say?
Yeah.
No, that's not Colin though.
Throw away the key.
That's not Colin. That's Colin.
What do I say? Colin and not Colin?
Yeah.
You call me like none of those.
6x squared
Call me dog.
and a 3x squared.
I'm not your dog.
But notice, here's another x squared. So 6x squared plus 3x squared is 9x squared. 9x squared minus 8x squared makes
X squared.
1x squared. All right, now let's do the y's. Negative 4y plus 3y is negative 1y. Negative 1y minus 2y makes negative 3y. Done. Okay, so can we add polynomials? Yes or no? Yes. So now let's think about subtracting. How can you turn any type of subtraction problem into an addition problem? So turn it to a plus and then make everything else a negative, right? So the same thing's going to apply when we go to subtracting our polynomials. So let's do this binomial minus a monomial. So we've got x to the third plus 4y, and then we're going to subtract from it 2x to the third. So I can easily turn this into an addition problem by turning my subtraction into a plus, which then means I need to turn everything that's in the second parenthesis into the opposite sign. Right now this is a positive 2x to the third, so I'm going to turn this into a negative.
Why wouldn't you do the first?
Because that's just the rule of subtraction. Like if I had 3 minus 5,
Keep change.
right, it would be 3 plus negative 5.
Yeah.
I wouldn't make the 3 a negative.
Or can you?
You can, if you in your brain can think that it's subtraction, you may do that. It's just sometimes when you get to a long polynomial as a second term and you got a bunch of negatives, then it just gets crazy. Taylor.
If the 2x to the third, if it was already negative,
Then it would become a positive. Yeah. All right, so now let's just add like we have been doing. Here I have an x to the third. I'm going to add to that x to the third a negative 2x to the third to make negative x to the third. Does the 4y have anything to add to? So it comes down. So this would be a cubic binomial. Good. All right, let's do one that's a little bit longer.
Technically, there is only 2 terms.
Yeah,
So how would it be cubic? Since cubic's 3.
the degree was 3 on the highest.
Binomial's 2.
All right, let's write it out. So we've got, I'm just going to use the words so you get used to hearing them. We've got a quartic binomial, and we're subtracting from it a quartic trinomial. So 7m to the fourth minus 2m squared minus 5m to the fourth minus 5m plus 8. So I can turn this into an addition problem. I'm going to make a new line. You guys are welcome to just do it in wherever it is you're writing. If I change this to a positive, then I have to change the sign of every term in the second polynomial. So my positive 5m to the fourth will become a negative 5m to the fourth. My negative 5m is going to become a positive 5m. My positive 8 is going to become a negative 8. So now I'm just going to add my 2 polynomials together. So 7m to the fourth plus negative 5m to the fourth, 2m to the fourth. And we got negative 2m squared. Do I have any m squareds over there? Nope, so just bring that down. Negative 2m squared. Plus 5m minus 8. Good. So I end up with a quartic polynomial of 4 terms. That's my final answer. Think you got this? Do we need to do another example?
No.